Hello, students. This is the Maths Rabbi. If you have been looking for a tutor who can take you through maths the fun and enjoyable way, if you've been looking out for a tutor who can take you through maths with very clear explanations, if you've been looking for a teacher who can take you through maths using very clear, well explained solution strategies, then I'm here with you. I'll be taking you through all the topics of mathematics, including probability algebra, including vectors, including calculus, including circles, the easy and fun way. Share this video and subscribe. Let's start our lesson for today. Today's lesson is about solution of simultaneous equations using the elimination method. I'll take you through 3 examples that should help you to solve simultaneous equations coming in any form. Solve for x and y in the pair of simultaneous equations below. These are x plus y is 5 and x minus y equals to 1. Now, how are we going to do this? We seek to eliminate one of the unknowns. The unknowns in this case are x and y. So we seek to eliminate either x or y. For this particular example, let us eliminate x. Now, we write them and seek to subtract them downwards. That is, we're going to subtract x from x, negative y from y, and 1 from 5. You notice that when we do it that way, x take away x is 0. So we don't have to write it. And y take away negative y will give us 2y. While on the right hand side, 5 take away 1 is 4. So we all know that y take away negative y is like y plus y, which gives us 4. So 2y is 4, and when we divide by 2 on both sides, y is equal to 2. So easily we have found one of the solutions, and that is y is 2. Now, we now do the second part, which is looking for x. To do that, we're going to substitute the value of y that we found into the first or second equation. For this case, I choose to substitute the value of y into equation 1, which we were given as x plus y is equal to 5, and we already know y is 2, so x plus 2 will be 5, and to get the value of x, subtract 2 on both sides, x is 3. This example has shown us clearly how to find both values of x and y, which we have as x is 3 and y is 2. In this case, we are given, again, a pair of simultaneous equations. The first one is 2x plus 2y is 10, while the second one is 5x plus 6y equals to 28. Now, how do we work this out? You notice that in this particular example, the values of x are different, and the values of y are also different. So, to do this, we will have to find a way to make the terms in x the same, or the terms in y the same. All depends on what you want to eliminate. In this case, I'll be interested in eliminating x. We're going to do that by making the terms in x to be the same. How do we do that? Now, just supposing we multiplied the first equation, equation 1, by 5, and we multiplied the second equation, equation 2, by 2. You notice that we're going to have 10x plus 10y giving us 50. For the second one, we're going to multiply by 2. It's going to be 10x plus 12y should be equal to 56. The terms in x are now the same. So we can subtract downwards and get our value of y. Let's subtract downwards. 10x, take away 10x will be 0. We don't need to write it. While 10y, take away 12y will give us negative 2y. On the right hand side, 50, take away 56 is negative 6. So negative 2y is equal to negative 6. And we divide both sides by negative 2. Clearly, y is 3. We found y. It should be easy now for us to find x. We're going to do that by substituting the value of y, which we got to be 3, into either the first equation or the second equation, the two original equations that we were given. In this particular example, I'm going to substitute y into equation 2. I choose 2 for just purposes of breaking monotony, but remember you can still substitute it into the first equation. Now we have 5x plus 6y equals 28, but we already know the value of y. So we're going to have 5x plus 6 times 3 equal to 28. 6 times 3 is 18, so 5x plus 18 is 28. And we subtract 18 from both sides and have 5x being equal to only 10. To find x, we divide by 5 both sides, and x is 2. We do have our two solutions for x and y, which are x is 2 and y is 3. Let us look at the third example, which is 8x minus 3y equals 24. And 5x plus 4y equals to 62. Now again, the terms in x are not the same, the terms in y are not the same. Let us break the monotony by this time eliminating y. To do that, we'll have to multiply the first equation by 4 and multiply the second equation by 3. So what do we have? 8x times 4 is 32, so 32x minus 12y equals to 96, while the second equation becomes 15x plus 12y equals to 186. Now we're going to add downwards. Why adding? Because the signs before 12y in the first equation, the first sign is negative, while the sign before 12y is plus. So the only way to eliminate y is through addition, not subtraction. Now when we add 32x plus 15x, it gives us 47x, while negative 12y plus 12y is 0, and 96 plus 186 is 282. When we divide by 47 both sides, I see this a division missing, but 47x divided by 47 will be equal to 282 divided by 47. X is 6. To now find the value of y, we are going to substitute the value of x into one of the equations. For purposes of this example, I choose to substitute the value of x into the second equation. It read 5x plus 4y equals to 62. When I put x 6, I'm going to have 5 times 6 plus 4y is 62. Now 5 by 6 is 30 plus 4y equals to 62. Subtract 30 both sides. 4y is 32. We divide by 4 on both sides to get y being 8. We do have our solutions for x and y. There are three methods of solving simultaneous equations other than elimination method, and they are the substitution method, use of graphs, and the use of matrices. But for today, we learned that we need to eliminate one of the unknowns, either using addition or subtraction. And then you find the solved solution by substituting it into one of the original equations to have your final solution. Thank you guys for watching. Please share and subscribe. Thank you.